training about swak4Foam and PyFoam. And in this training, I'm going to demonstrate how to take a tutorial case and do some evaluations with it and do some other crazy stuff that you couldn't do before. The thing is, basically, you might have seen it already. There's 150 slides approximately. So I'm going to go rather fast through it. I'm going to show an interactive part in the beginning, but then I'm going to go rather fast. I think it should be possible to follow the slides afterwards to reproduce everything. And all the material that you need for this is also available, and that's described in the slides. And if we're lucky, then I'm going to finish before time, and you can ask some specific questions if you have them afterwards. Okay, this presentation is about two libraries, toolkits, swak4Foam and PyFoam. These are quite different beasts. The thing that they have in common is that they're both used with OpenFoam, and they're both written by me. And the thing why I combine them in a presentation is I used to have introductory presentations about the two of them, but it's quite hard for me to use one without the other. You will see afterwards why. The intended audience for this is basically everybody who's interested, but so the only knowledge that I assume that you have is that you have done a bit of work on a command line like Linux, and that you have started OpenFoam cases a couple of times. But there will be no programming. So basically, this is designed as a hands-on tutorial. It works as a hands-on tutorial if we had 2 times the time. So as I said, I'm going to go a bit faster through it. I'm going to skip some stuff that I think is not as essential. If you have questions about these, ask me afterwards or send me an email. Yeah. So basically, some words about me. I've been working with OpenFoam since its first release, but I still have to look up things on the Doxygen. So I'm not really an enthusiast like they call people who are not core developers. My involvement in the OpenFoam community is that I'm in charge of the OpenFoam wiki, and I wrote these utilities, and I'm in the committee of the workshop. But that is not my main work. That is only collateral damage from my real work at Heinemann Fluid Dynamics Research, which is a consulting company located in Austria. Yeah. So basically, so PyFoam, the first thing is PyFoam. That is a Python library that manipulates cases and controls OpenFoam runs. It has very few dependencies. So basically, essentially, it doesn't even need an OpenFoam installation. The thing is, without an OpenFoam installation, it wouldn't have too much stuff to work with. And usually, people don't come in contact with the library. There's a number of utilities for these that can be used for case manipulation, running simulations, and post-processing the results. If you want to see how to use PyFoam as a library, there will be a training that I will give tomorrow about that. So it's quite easy to find all the utilities that are in PyFoam. You basically just type PyFoam, and then you use the tab completion of your shell, and depending on what shell you use, it gives you a complete list of all the utilities that are there. And all of the utilities have a help option that gives you a list of a description of the utility and all the options. Apart from that, there is only the only documentation there is the wiki page of PyFoam. It's not that much. The other thing is swak4Foam. Swak4Foam. Swak means, I have been told that in Afrikaans this means weak, but originally swak stands for Swiss Army knife for foam. And it's like a Swiss Army knife. It can be used for almost everything, but sometimes it's not the best tool for these things, especially if you have to be memory efficient. And it's the result of some utilities that I did before, funky set fields, groovy BC, and simple function objects. I've thrown them together and it has since grown to a much bigger thing. And basically the goal of swak4Foam is to make it unnecessary for you to do C++ programming, even if you need complex boundary conditions, non-standard evaluations, and things like these. The core of swak4Foam is a so-called parser. A parser is a program that takes a textual input from you and tries to interpret it. And what this means is that, for instance, if you enter t minus 273.15, it means for swak4Foam, okay, give me find the field t, whatever that is, usually it's the temperature, and subtract it with this number and give me back the field that is the result of that so that we can work with it. And you can, these kinds of expressions in swak4Foam, you can have on all kinds of entities in OpenFoam. You can have them on patches, you can have them on internal fields, but you can also work on face sets and cell zones and things like this. And there is and that is the core, and there is a couple of utilities, function objects and boundary conditions, which are built on this. And the reason why I wrote this is that in the beginning you had, if you wanted to do a non-standard evaluation, you had to write a C++ program to do it for you. And you never had a need for that C++ program again. And that, or if you needed it, it was broken because of an OpenFoam update. And with swak4Foam, I tried to avoid using such throwaway programs. Okay, so before we start, there will be a lot of command line examples. They will look the way you see it up here. Sorry. Okay, the way it looks up here. This sign basically means, okay, there's an input after that. If that sign isn't there, then it means, okay, this is output of the command. If the examples are longer, they will be in these gray boxes. And if you see italic, this brick, and cont, these are not to be typed. This just means, okay, the line is broken at this place. For working with this, you will need a terminal and a text editor. For a text editor, use whatever you like. On the Docker image, there's Gianni installed. That's a fairly standard text editor. I just installed it because it was the one with the that looked almost like Notepad on Windows and had the lowest memory footprint. For this presentation, you basically need a machine with OpenFoam 7.0. Older versions should work as well. Foam Extend or DSI, the latest version, should work as well. There should have been swak4Foam and PyFoam installed. As installing swak4Foam is something that involves compiling and would need approximately an hour to compile. I prepared a Docker image with all the necessary stuff, and there's also the training material in this Docker image. The Docker image should be able to run on Linux, Windows, and Mac OS X. I have only tested it on Linux. It's based on Ubuntu 18.4. It has OpenFOAM 7, as I said. It has the latest version of PyFoam and the latest version of swak4Foam. Pulling the Docker image needs approximately 2 gig of bandwidth of download. I have added the commands here. Let me see. So basically, you pull the Docker image. Okay, that's the wrong image, but anyhow. Then the next thing you have to do is I wrote a script that runs the Docker image. You have to get that one. The command is on the slides. So basically, you get that one. Then you have to make that command executable. And now, if you run the command and you give it the name of the Docker image that we pulled, then now we're inside of the Docker image. The thing is, we're now in the Docker image, we're in a directory foam data. And when you look at this directory foam data, this is exactly the directory on the host machine. So basically, if we do anything in this directory, for instance, I touch this file and then I exit the Docker image, then the file is on your host machine. So you can work with this Docker image, and as long as you store stuff in foam data, you still have it after the Docker image has ended. So that's that. Okay, these are the things that I've already shown. And now to get the material, basically everything we do should be written out on the slides, but to give you the possibility to catch up if something happened too fast. There are 4 discrete phases which are wrote out to disk. There are 2 ways to get these. One of them is if you have the Docker image, then if you enter the image, there's a directory examples. And if we want to get the first phase of this, then I just have to copy it to the current directory. And it's there. And now that is basically on your host machine as well. So the first thing is we make sure that PyFoam is working. One utility that you hopefully don't need that often is PyFoam version. PyFoam version, when you run it, gives a whole lot of output. It's somewhere in there, there's the actual version of PyFoam is buried. It gives information about the Python version used and things like these. This utility is quite useful if you have a problem with installing or running PyFoam and you want to get help from me. Then one of the things that I'm going to ask you for is, okay, please at first give me the output of PyFoam version, because that way I can tell, okay, that might be the problem, like mixed library paths and things like these. The other thing to make sure that swak4Foam is working is basically running funky set fields. And here the interesting output is this swak version. Also, if you need help, please give me the swak version, because then I can say, okay, long known error has already been fixed since half a year ago. So, okay. So the first thing that we now do is use the first PyFoam utility. And one of the utilities that PyFoam has is PyFoam clone case. That utility is basically, it copies a case, but it only copies the stuff that you need to start the case. So basically it copies the zero time directory, constant directory, and system directory. So the case that we start with is, sorry, I can't see what I'm typing because this Zoom stuff is in the way. So basically one way would be to copy this over. And let's see. Yeah. And one thing that you will now see in this case is, for instance, the first sign that PyFoam has worked here. That's, for instance, that's PyFoam history. That is basically, that's a file where I record every time you modify or run this case with a PyFoam utility, then it's recorded here. So that way you can still tell, okay, that was the command that I used last time to run this. So basically the only line it now has in this PyFoam history is that it says, okay, I was cloned from this location. Yeah. And for the next stuff, I'm going to go to the prepared case that we have here. And now I modified this case. I moved 0 to 0.org. The reason is that I usually set up my cases with a utility I call PyFoam prepare case, to which I give the case that I want to prepare, which is the current case. And that utility automatically, utility automatically copies over the 0.org directory to the 0 location. That way, because I do that because some OpenFoam utilities, they like to overwrite stuff that is in the 0 directory. And if you hand edited these files yourself, then the stuff is gone. So I think it's better to basically to start off with a directory that OpenFoam usually doesn't touch, copy it over to 0, and then do things like running block mesh. And so basically this PyFoam prepare case, if it finds a block mesh dict, it runs block mesh automatically. If it finds set fields dict, then it runs set fields automatically. So that way the case is now set up and can be run. PyFoam prepare case can do a lot of other things, but yeah, but there is a separate presentation about that that I think was held in Shanghai 2 years ago. Okay, so now comes the interesting part. Now we say, okay, we would like to run this case. Usually you would start the solver by hand, and what I usually do is that I use PyFoam plot runner. This PyFoam plot runner implements half of the functionality that I was missing from Fluent. That was basically looking at the residuals while the case was running and seeing, okay, converges, doesn't converge. The other thing that I miss from Fluent is that you give it any crazy boundary condition and it doesn't crash. Okay, so what I usually do add now is clear. I'm going to explain that later. Progress, you will see later, that's basically that swallows all the output and just says us, okay, we're calculating this time. Auto, we don't really need it now. Auto is basically when PyFoam finds processor directories, then it says, okay, he gave me auto, so he wants me to be clever. Instead of running the solver in serial mode, I'm going to run it with MPI run because it's a parallel run, obviously. And the last thing that I then tell it is, instead of this, you can give the solver name. I usually give auto. And with that, PyFoam looks into the control dict, says, okay, that's the solver that I'm supposed to run, and it runs that solver instead of this. And when I type enter, sorry, there's okay, D was missing. One of the things is that with PyFoam you don't have to spell out the options. If the first part of the option is there and if it's unique, then PyFoam says, okay, everything is fine, I'm doing this. Now when I run this, you see that the time is running there and you see the residuals of the solver. So I guess this is the most used utility of PyFoam. As I said, as you've already seen, it plots these nice. It uses GNU-plot to plot residuals and things. So let's see. Yeah. Now the run has already finished, and one of the things is sometimes, and now we see that there are the regular time directories that you would expect in this, and there's a number of other files that PyFoam wrote. To know that PyFoam wrote it, they have PyFoam in front. It's the log files. That's the output of the commands. So you automatically get the log of the simulation run that you did. The hard copy option that I added, this basically shows generates hard copies of the files of the plots that you did. And one of the things is that sometimes you don't run your stuff through PyFoam. You run your runs through the batch, the queuing system on wherever you work. And usually these queuing systems, they produce log files like the PyFoam runner Bion Pimple Foam log file that we have. And if you want to have a look at the plots from these, there is the PyFoam plot watcher. and you say PyFoam plot watcher, then you give the point it to the log file that you're interested in. And now what this does is it analyzes the log file and it gives you exactly the same plots that the PyFoam plot runner would have given you. The nice thing about the watcher, that's why it's called the watcher, is it assumes that the log file that you look at is that you pointed it at is still alive, so that the run is still going on. So if you point it to a log file from a run that is still running, it will update itself. And you can also tell it to give you additional plots with all, for instance. You get the execution time of each time step. So it says, okay, time steps went quite fast. You get the Courant number, you get the number of iterations. And later we will see that how we can add our own plotting information. So, yeah, the next part I'm going to go quite quickly over because that is something that doesn't work on the Docker image because I didn't install ParaView on the Docker image. Let's be honest, ParaView is something that, in my experience, only is problematic with Docker images. It usually wants some kernel modules that are not available on the MacBook that people use the Docker image on, and then everything goes. Okay. So, but I don't know how many of you have already worked with state files. State files in ParaView, that is something that is really great. Basically, what you do is you click your visualization in ParaView, like something that looks like this. Once you're satisfied with the visualization, then you go to the file menu and you say save state, and it saves a state file. And then you close ParaView, and if you want to show your boss the visualization again, then you just open ParaView, open the state file, and you get exactly the same visualization again. And what PyFoam does is it has a utility, or it has two utilities that allow you to work with these state files. It allows you to point the state file to a different case, to say, so basically you prepared the visualization with one case, and then you want to use it with a different case. That's the one thing. And the other thing is, and that's something with which I sometimes don't have to open ParaViews for days, is basically you give it a case, you give it a state file, and it produces a number of screenshots for you. And afterwards, yeah. So it doesn't really even open the GUI. And one of the things that these utility does is if there is something like here where I entered this % brackets case name S, if I enter this in a text, then the utility replaces it with the current case. Okay, so that's the way it looks like when I call it on the command line. I say, okay, sorry, PyFoam PV snapshot, that's the utility. Then I say, use the state file that I added. The state file is also in the material of that you get. And then I say, okay, please take the time 200 and take the latest time and just create me bitmaps from these. And when I do this, then I get, for instance, then I get these screenshots from the time 200 and the time 2000. So this can save you a lot of time, especially if you have to do repetitive visualizations of a lot of similar cases. Then it's quite easy to do this with this. Okay, but as you know, the visualizations are nice to look at, but what you usually need are the numbers. So this brings us to the first swak utility that we're going to use here. That's field report. Field report is something, sometimes you just open ParaView just to look at, okay, what's the highest temperature I have here? And once you have that, then you're satisfied. So basically, the idea behind this utility is that you say, okay, take the time 200 and the field temperature. And when I run it, it just gives us some basic statistics about the field. Not all of these make sense for every field. For instance, yeah, there's no use in summing up the temperature. But summing up the temperature, especially if it's a weighted sum of the energy of the enthalpy, is a completely different thing, because then you get the enthalpy in the whole case. Weighted in swak4Foam means usually weighted with the size of the cells. So if you have a weighted sum, then it's really a volume integral over your case. Okay, field report can do a number of other things. You can also get the values from patches. And if you don't like visualizing stuff with gnuplot, then what it can also do is it writes out comma-separated value files, CSV files, and you can import these then into Excel and do your analysis in Excel. Okay, now that we've worked with it, we want to throw away the stuff in the case, but we don't want to throw everything away. We just want to throw away the stuff that the simulation generated. And for that, there's this PyFoam clear case utility, which has a number of options. For instance, verbose to tell me what it clears away, and keep the last time step. Okay, that's for instance, that's one of the instances where it says, okay, verbose is not enough. I have two options that start with this. Then I have to tell it, okay, verbose clear, and it clears the case and removes all the time steps except for the initial one and the last one. There's also a utility for packing everything that is essential. So basically system constant and the initial time directory into one tar file so that you can archive it if you want it. Okay, so that was the initial setup and running with PyFoam. And now the next thing that we do is we start working with swak4Foam with the expressions that I promised you before. I think I'm now not going to show you the stuff on the command line. I think you're now sufficiently convinced that everything works in Docker image as I promised, and I'll show you these things now on the slide. Funky set fields is basically the oldest part of swak4Foam. It used to be a standalone utility. Funky set fields was basically I wanted to do something, have something like set fields. but I wanted it to have a bit more functionality. And I think it would have sounded preposterous if I called it super set fields or plus set fields. So I settled for funky set fields. So the idea is you specify an expression and the utility creates a field and their values. The most important options are those that specify which time to use. Then you have to say, okay, with which field will I be working with? Then you have to tell it with create to create a new field, and then you give it the expression. You say, okay, what expression should we use? And there's an optional thing that is a condition that says, so you can have funky set fields not work in the whole region, but you can tell it, okay, please only set a part of the field. So for instance, one thing is, as we know, PyFoam stores the temperature in Kelvin, which for most of people isn't that hard to calculate, to get into their usual reference frame. They just say, okay, we subtract 273, and then we have the Celsius, and I can say, okay, then I can live with that. For those people who still use Fahrenheit, it's a bit harder because 300 Kelvin, how much Fahrenheit is that? So what I demonstrate here is basically to create a new temperature field in Fahrenheit. If you have somebody who wants their post-processing done in Fahrenheit, you just say, okay, create a field T Fahrenheit and use the expression, I hope it's correct, I looked it up on Wikipedia, T times 9/5 minus 459.67. You run this. What I tell it with time, that is not swak4Foam specific, that's PyFoam specific. I say time 0 colon. This means start with the time 0 and do this for all other time steps in between. And it writes out these things, and you, for instance, now you can check the field report. You can now say, okay, write me out the temperature in Fahrenheit at all these times. Now what I'm doing now is I'm replacing the set fields dict that this hot room tutorial. Oh, I never talked about the hot room tutorial. I never said, okay, what's this hot room tutorial about? That hot room tutorial is basically a room with, I think, 2 meters high, 4 by 4 meters wide. And in the middle of the room, there is a fireplace or something like that. That's 1 by 1 meter. And this fireplace is set to a temperature of 600 Kelvin by this set field dict. And the first thing that I want to do is I want to replace this set field dict with the funky set field. So I remove the set field dict, and now I try to replace this with a more flexible expression. Now, because I don't create a new field, that's why I'm not using the minus create option. And one of the things when you're manipulating fields that is quite important is basically to say keep patches. Keep patches keeps all the information in the boundary patches of the field intact, except for value patches. I tell it value patches is floor. There I say, okay, replace values in this patch with the values that you calculated for the field. Then I say, okay, do this for the temperature field. And then I have this rather longish expression. Not going to go. Basically, what this expression means is take. So I start here. Take position. Position is a vector that is the position of each cell. Take the position. Take the x value of the position, and compare it to 4.5. This is for those people who programmed in a C-type language, that's C++, Java, C#, C, whatever. A lot of languages use this. This is a logical AND. This means this condition has to be true, the next condition has to be true, and the next condition has to be true, and the next condition has to be true. So I say, okay, set the field to 600 if these 4 conditions are all true. And what you get is something like this, a temperature field like this. This is a bit, looks like a column of fire. That's not exactly what we wanted, but the essential thing is that on the floor that you see as a grid, the temperature is now 600. And we're going to remove the column of fire in the next step. But first, something about the expression syntax. The expression syntax of swak4Foam is modeled on the expression syntax of C++. It has the usual operators, plus, multiplication, and things like these. Some of the special operators, it takes their meaning from OpenFoam. In OpenFoam, the inner product of two vectors, for instance, is given by this ampersand, and the outer product is given by this head operator, and swak4Foam uses them with the same meaning. If you want to know more information about what expressions are possible, which functions are built into swak4Foam, there is a bit of documentation that comes with swak4Foam that's called the incomplete reference guide, and you find it in the documentation directory of the swak4Foam sources. Okay, so now we want to clean the column of fire away. That's quite easy. We basically just say, okay, take the temperature field, keep all the patches, and just set it to 300. So basically this sets the inner field to 300, but on the floor we still have this patch with 600 degrees Kelvin. And now we can run it. And the thing is that it's a bit tedious to call funky set fields every time by hand. And one of the things that PyFoam prepared case does is after it set up the mesh, it looks for a script file that's called casesetup.sh. And it executes the commands that are in there. So basically what we do is we create such a script file, and we copy paste the 2 commands that we first tried on the command line. We copy them into the script file. And now whenever we run PyFoam prepare case, these are executed automatically. Okay, now we get to the evaluation part, to the function objects. Function objects, for those who don't know it yet, are basically small programs that will be loaded when that you specify in the control dict. They will be loaded when the solver starts, and then they will be executed at every time step. So you can do a lot of things with these. most of these things involve post-processing. So usually if you want to calculate the heat transfer coefficients, then this isn't built into any solver. You look for the function object that calculates the heat transfer coefficients, and you specify that in control dict. And most of the functionality in swak4Foam comes from such function objects. At first, you have to tell OpenFoam where it finds these or that it should load these function objects, and you tell it with this libs entry that is a list, and in this list you give it all the libraries that it should load when it starts up. And what we add here is the simple swak function objects. These are function objects that can be used for evaluating stuff. Okay, and to evaluate the temperature, for instance, we have to add the function to the control dict. You add a dictionary functions to it, then OpenFoam, if OpenFoam finds that, it says, okay, function objects here, I will load all the function objects that I find here. And then I specify a function object called temperatures. And the thing that OpenFoam requires you is that you say, okay, what is the type of this function object? I specify here, I say it's a swak expression. With a swak expression, I have to tell it, okay, I want to evaluate this, but where do I want to evaluate this? If you want to evaluate it on the internal field, you say, okay, internal field. We will see other examples later. Then I say verbose true. I say, okay, write the results to disk, but please also print them out on the screen with a line. And then I say, in this case, the expression is rather simple. I say, okay, take the field temperature. Now the fields can be potentially rather large, and we don't want to write out 10,000 numbers. We want to boil them down to 1 or 2 numbers. And boiling down to 1 or 2 numbers is called, in swak4Foam, it's called accumulations. And and there is a number of accumulations. Here I specified 5 of them. I said, okay, take the minimum, take the maximum, and the one in the middle is easiest to understand. That's the weighted average. That's basically the volume weighted average value of the temperature. Because you can use average without weighted as well, but that would be the arithmetic average. So basically, if you have very large and very small cells, then the very small cells would have a very big influence on the average of the temperature. Weighted average is usually what you want if you want the real physical average number. And weighted quantile 0.1 is something similar. It says, okay, give me the temperature where 10% of the volume has a smaller temperature and 90% has a bigger temperature. And weighted quantile 0.9 is something similar. These quantiles are quite nice to give you a feeling on how the function is distributed. And you can use, with these weighted quantiles, you can use any number between 0 and 1. So basically, weighted quantile 0.5 would be the same as weighted average. Okay, that's what I already explained. So now we can run the evaluation. And now what you see when you evaluate it, you see a typical line that's here, expression temperature. And it writes out the 5 accumulations that we did, the minimum, the maximum, weighted quantiles, and the weighted average. And you say, okay, that's nice, but I want a picture. I want to see how things evolve. And one of the possibilities would be to look at the post-processing swak expression temperatures, 0 temperatures. There's a file with all these values, but to plot them during the run, we can tell PyFoam to plot these values for us. The way it works is swak4Foam writes the stuff to the console. PyFoam grabs that output, it analyzes it, and if it says, okay, I recognize this is the temperature, then it will plot it. And to recognize it, we need something called regular expressions. Regular expressions, I'm not going, I think we're running out of time anyway. So regular expressions are basically you specify a pattern and you say, if this looks like a pattern, then it matches, and then please give me some parts of the pattern. Letters, for instance, match letter, and then there's a special thing that's the dot. The dot matches, for instance, does match any letter. And the important thing with PyFoam is that if you have parentheses, then they group something together. And if something is grouped together, then PyFoam will convert it to a number and plot it. And you specify that in the so-called custom regex file. If PyFoam finds this file, custom regex, in the case directory, it says, okay, he wants me to analyze stuff. I will do that, and I will happily plot the stuff. And then what you specify here is you say, okay, I want to plot something called temperature. The title of the plot will be temperature. I want a label on the y-axis that says, okay, this is the temperature in Kelvin. And then I say, okay, match this regular expression. So basically I usually I copy paste the line from one line from the output. And then I replace the numbers that I want to find with parentheses, dot plus parentheses. And what I can then do is also say, okay, the first thing that we find is the minimum. So this is the minimum. The second thing that we find is 10%, third is average, and so on. And now if I run the PyFoam plot runner, it automatically plots something like this, where it plots the temperature, and it gives us a legend of which colored line means what. Okay, I can also do this kind of plotting, for instance, with a special function object that's called patch expression. Patch expressions are similar, just they do the calculation on patches, and I have to give it a list of patches. I say, okay, give me the temperature on the floor, the ceiling, and the walls. The only difference that I have here is I don't use the temperature directly on the patch, but one cell next to the patch. The reason for this is that otherwise on the floor, where we have these cells with 600 degrees Celsius, we would get 600, and this would mess up the scaling of the plot. So there is, for instance, for patches, there's a function that's called internal field of the temperature that says, okay, don't give me the temperature directly on the patch face, give me the temperature in the next cell to this face. And when we add this, then we get a lot of output. We get the temperatures, we get the wall temperatures. And for instance, when you look here at the output from the floor, yeah, when you look at the wall temperatures on the floor, you see that it's okay. It's 300 minimum. It has a weighted average of 303, and the maximum that you get is 600. That's not really scaling nicely. and we can add the output for this and the thing is, this is a lot of output, and so there's a new type. I can specify a type dynamic for in the custom regex, where I say, okay, one of the patterns that you will find is a name, and please create a special data line for that name. So here we have the pattern temperatures internal on, then there's the pattern for the patch, and then there are the patterns for the numbers. So what we now get is a plot where we have for the ceiling, we have five lines for the ceiling, we have 5 lines for the fixed walls, and we have 5 lines for the floor, which starts to become a bit confusing because GNU-plot starts reusing colors, but that's not my fault. Okay, and now the last thing in this bound is there swak4Foam has another function object that is basically like funky set fields, but it happens during the calculation. For this, we have to add another library, the swak function objects library to it. And this function object is called expression field. Expression field, I give it a field name, that's T Fahrenheit, that's the temperature in Fahrenheit. Then I have to give it an expression. And basically what expression field does is it, at the end of every time step, it takes the temperature, it calculates a new value from this, and either we can use this field then in other calculations, or if we specify auto write true, then every time the solution gets written to disk, the field is written as well. So now I get this temperature in Fahrenheit without even having to run funky set fields afterwards. I'm going to skip over this. You can, I'm not going to skip because there's something essential here. Funky set fields, instead of specifying everything on the command line, you can specify things in a dictionary as well. So if it doesn't find an expression, it will look for a dictionary file and it will get its information from there. And there are some things where you're more flexible. The thing that you're more flexible with this dictionary mode for funky set fields is that you get to specify variables. Variables is something where you, where you can store intermediate results and reuse them. This makes large expressions more readable. It makes some computations possible that wouldn't be possible otherwise. The only thing is that it might use a bit more memory because all the intermediate results are stored as fields. So if you have a large case on a small machine, you might run out of memory, but it's hard to do that, let's say it like this. And what we do here is that I said, okay, I want to have something like a dimensionless velocity. So I want to take the velocity and I want to divide it with the longest, with the largest length of my geometry. And that is calculated here. I say the length in the X direction is, give me the maximum of the point values minus the minimum of the point values. This is not POS. POS would be the cell center. PTS are really the positions of the points. The problem here is just that all these calculations, this gives you a point value. All these calculations are point values, are specified on the points. So in the end, to reuse L max, you have to interpolate it to the cell values. That has to do with what I call native versus secondary structures in OpenFOAM. Native is usually the cell value is the native value, while the values on the faces and the points are secondary. And usually swak4Foam tries to use the primary value, the native value, and you have to interpolate for the others. But stuff like the point positions, they are only specified on the points, obviously. This is explained in more detail in the incomplete reference guide. Okay. Yeah, this is just something that is quite nice. You can have a more colorful output for some of the PyFoam utility if you use the option curses. If you use that, then you get something like this, where on the bottom you get the progress, a progress bar of the run, you get the current time step, you get the output. The output is colored. If it matched an expression, then it's so everything that matched an expression, like here, for instance, the temperatures, is colored differently so that you see that you will get plots of this. Okay, this is in the second tar file. Okay, I'm going quickly through part 4, and I'm just going to tell you then what is in part 5, because I think then basically time will almost have run out. But the next thing is we will talk about is Groovy BC. That is basically a boundary condition where you can specify the boundary condition through expressions. The first thing is, for instance, here what I did is I cloned case. And one nice utility is PyFoam list cases. PyFoam list cases is basically like LS, but for OpenFOAM cases. It looks at directories, says, okay, this directory has system constant, so it seems to be an OpenFOAM case, so I will list it, and it looks into the case, says, okay, there are time steps from 0 to 2000 there, and you can have additional information. If you want to know more about this utility, use the -- help option to give you help about this. So for Groovy boundary condition, we have to add another library, the Groovy BC. We add that to the control dict, and the Groovy boundary condition is based on the mixed boundary condition. I don't know if you have ever worked with the mixed boundary condition in OpenFOAM before. That is basically a mixture of the fixed value and a fixed gradient boundary condition. And therefore, in Groovy BC, you can specify 3 expressions. You only have to specify the first one. The other ones are optional. That is the value expression. That's basically, if you specified only that one, then it behaves like a fixed value boundary condition, but it uses the value that you specified in this expression. If you want to have a fixed gradient for some reason, then there's this gradient expression. And if you want to use that, then you have to specify also the fraction expression. The fraction expression tells us whether this is a fixed value or a fixed gradient boundary condition. If it's 1, then it's a fixed value condition. If it's 0, it's a fixed gradient. And if you have any number in between, then it's a weighted in between of these, of fixed value and fixed gradient. Okay, but today we'll only use this. So now what I want to do here is that the heater that we used to have in the middle of the room, I want to do something that I can't do with set fields. I want to have a circle with a diameter of 1.5 meters. And I want this, this circle to move around on another circle that is also 1.5 meters long. So basically we have a heater moving around the room. Something I think that the fire marshal won't approve of. But anyway, so what I specify here is you can, I think I'm not going to explain it in detail. I say, okay, this, the center of the first circle is this. I specify the radius and the radius of the fire and the radius of the circle here. And then I say, okay, at which angle should the fire now be? I do this by taking 2 pi times, and this is a special function. This time function gives you the current time of the simulation. So if the simulation is at 255, then time has the value 255, and it will be inserted here. And that's the way how we get this thing moving. And what I then say is, okay, if the current phase position minus the middle of the fire, if the magnitude of that is smaller than the radius of the fire, then we take the high temperature. Otherwise, we take the low temperature. This question mark colon is something that's quite common in C and C++. That is a condition that's basically an if expression in one line. One of the things with Groovy boundary condition is if you start to write complicated boundary conditions, then with complicated things, complicated errors can happen. And to find complicated errors, you need simple utilities. And the simple utility that is used here for that, that's replay transient boundary condition. That is basically something that you start. It reads the files, including their boundary conditions, and it doesn't do anything else but progress the time. And at each time says to the boundary conditions, okay, evaluate yourself and write to disk. So what you get is it runs quite fast. You can first specify the boundary condition, then let it run. And then you can open ParaView and see if the boundary condition behaves really the way you want to over time till the end of the simulation. Because there's nothing worse than starting a run on Friday, coming back to the office on Monday. The run went over the whole weekend, and you found out it calculated garbage because you did something wrong in one of the expressions. So it's easier to first test it with replay transient boundary condition and then waste valuable computation time. Okay, same procedure as every year. We run PyFoam prepared case, we run the PyFoam runner, and we get some new temperatures. Here they are a bit higher than they used to be because our heater is now bigger. And the wall temperatures are also different, obviously. And now what you see here for instance, if I use PyFoam PV snapshot on this, then I can have a look at the location of the heater. You see in the middle, you see the hot air. You see some kind of the flow lines. You see at time 200, the heater is on the right side of the room. And at time 2000, it's more on the left side of the room. So it's really moving around. So the next thing that I'm going to show you is there's a PyFoam has a lot of fields. Some of them are not automatically written, but every field that is found in memory can be accessed by swak4Foam. The thing is, how do I find out if the fields are there without looking through the source code? And what you can use for this is there's a, in swak4Foam, there is this list registered objects function object. That function object, if you inserted it, then it gives you a lot of output. At every time step, it writes out, okay, I have this field K. This field K is not auto-written. So if it's not auto-written, then it's usually not in the time steps, and so on. We have here, we have this field T for the temperature. It's a volume scalar field, and this is automatically written. The type is, you can't get the correct type for all of these. So basically most of these things might be fields as well. So that's the way how you can find out, is the information that I would need for my swak4Foam computation, does it exist, and under which name does it exist? This helps you with that. The other thing is there's a lot of function objects in swak4Foam. I mean, there's a lot of function objects in PyFoam as well. And the one way to get this is the so-called banana trick. Basically, if you want to find out which function objects are already in memory, these are only the function objects that have been loaded, then you just basically specify in a function object of type banana. There is no function object of type banana that I know of. And PyFoam thinks the same. So it says, okay, there's no function object type banana, but this is the list of the 90 function objects that I know. So if you say, okay, I think there should be a function object for what I want to do, then this is the easiest way to find out whether you have already loaded that function object. So one thing that is nice, if you have something like this heated room, then you might want to know what is the heat transfer, what is the heat flux on the walls. And for that, we use another function object. At first, what you do is you specify a new field file called heat flux. You add the usual stuff, you give it a dimension, it's dimensionless, which is not true. You say, okay, internal field is this. And then I say on all the boundaries, calculate a groovy boundary condition with this value expression, kappa times the surface normal gradient of the temperature. That would be the heat flux for each phase. I calculate kappa here from these. And one thing that you have to use with swak4Foam, if you have something like alpha of the thermal model, which has a colon in the name, swak4Foam can't deal with this. So you have to specify an alias. You say, okay, if the expression has alpha, then please use thermo alpha instead. So at first we specify this file. It would be this field file, as it's not known to the solver, it would be ignored. And what we now do is I say, okay, I add a new function object that's called read and update fields. And it's given a list of fields, in this case, only heat flux, which basically means, okay, read heat flux in the beginning of the simulation and calculate the boundary condition of this field. And the field gets automatically written at every time data is written. So now what you have is you have a field heat flux on disk that you can either analyze with field report, or you can visualize it in ParaView. Okay, I think I've got only a couple of minutes left, so I'm going to go through the rest quite fast. There's a utility called funky do calc, where you can do all these calculations after the simulation. Instead of doing the calculations with function objects, you can do them with funky do calc. It looks on disk for the data, and every data can use everything it finds on disk. So that is demonstrated here. Something that I'm going to skip over is it's called remote variables. That is something where in the regular variables, if there are these curly brackets in the variables, then this means, okay, this is a remote variable. This is calculated somewhere else. One typical application that I use this for is, for instance, the pressure drop. I specify an expression on the inlet and I say, okay, give me the pressure here minus the pressure, and please now look up the average pressure on the outlet, and with that I easily get the pressure drop. That is demonstrated here. I'm going to skip this again. So now what we see here now is for instance, now is the case where I visualized, where I used where you see the heat flux on the floor and on the bottom. Okay, and that's that. The last thing I'm just going to say, okay. The first section of this that I'm going to skip, that's about when you do the calculations, when you look at the average temperature, then on the average temperature on the floor, then it jumps quite rapidly. The reason is that we have this circle, and we switch only, and if the circle progresses, then one cell is switched on, another cell is switched off, and this gives two big spikes. So what I show here is how to make these spikes, you see them here, how to make them smaller by interpolating, by saying, okay, on the boundary of the circle, it shouldn't be 300 or 600, it should be something in between. Then I show how to port a rather a boundary condition that exists in the ESI version of PyFoam, but not in the foundation release. If you want to use, for instance, such a boundary condition, then you have the possibility to either try to get the C++ code to run there, or you can specify, or you can use Groovy boundary condition to emulate this. The interesting thing about this boundary condition is that it uses stored variables, which are variables that keep their values, where you can store stuff. And in this case, it stores the temperature of the wall over time, and it updates it. Okay. And the last thing is I show something, a utility that's called funky set boundary field. I mean, I think you now get what this does. Is it sets the boundary fields, and I show how to set coefficients. Let's see. Yeah, and I show how to set coefficients that are usually that PyFoam knows they can be uniform but non-uniform, but there is no utility to set them. And this shows how to use funky set boundary fields for this. Okay. So basically what has been done here is that I set a heat transfer coefficient on the walls. I set it to something very low where the walls are, and to a higher heat transfer coefficient where the windows are, which don't insulate as well. And because of this we get higher heat fluxes out of the windows, and I didn't have to specify different patches to do this. Okay. So yeah, as you've seen, I've there's a lot more. The presentation could have been 2 times longer, and I wouldn't have finished with the features in PyFoam and swak4Foam. There are other presentations that for further reading, you can go to the wiki. You can look at the examples that come with the swak4Foam sources. You can look at the incomplete reference guide for PyFoam. The utility, the help that you want is in the help option. Further presentations were given at previous workshops, for instance, PyFoam prepared case that was given in 2018. PyFoam for the lazy is about writing and reading data with PyFoam. State and solution, yeah. The other two are basically advanced topics in swak4Foam. And there will be a presentation programming with PyFoam that will be held tomorrow. Before I hand over to questions and the chair, I think there will be time for 1.5 questions. I just wanted to point out that on Friday, there is the Splash Talk session. Splash Talks, applications for the Splash Talks started to splash in. But there are still places available if you want to give a short presentation about something, what you're currently doing, about a project, about a fun simulation that you had, about some open source thing that you developed and that you want to advertise, then please send me an email. Please send me an email with what you want to present, and as long as there are slots, you will be fit in. Okay, thank you. Are there questions?
Okay, great. Thanks, Bernard. Can you see the chat? There's a question in there right now.
No.
Well, the question is, it says the tools are very powerful. I'm wondering if there is some functionality which is missing in the current swak4Foam and PyFoam. What should the users do? It seems difficult to understand how the utilities are coded for users.
Basically the question is, how can you contribute to swak4Foam or PyFoam?
Right, how could you modify it and extend it, it seems?
Yeah. Okay, so some of these things for PyFoam will be answered tomorrow when it's about programming with PyFoam, how to use PyFoam to set up your own workflow. For swak4Foam, it's a bit more complicated because basically it's coded in C++, so that has a quite high learning curve. I gave some years ago, I gave a talk at the third Zagreb workshop, which is I think 5 or 6 years ago. I gave a talk about programming for swak4Foam. Because there's something like function plugins where you can write function plugins in swak4Foam, and yeah, and with function plugins you can add additional functionality to extend the expressions. But yeah, if you have a concrete thing that you would like to do, then please contact me and I can at least point you in the right direction. Okay.
Great. Thank you. Are there any other questions or things people would like to know about?
Okay.
Okay, so there's 2 here. So Heinrich's asking, is it possible to calculate the difference of a field in 2 cases for the same mesh?
Yep. it's there is it's called mapped. You can have mapped fields where you have to specify the other case. The thing why I'm stuttering is I know I implemented it a couple of years ago. I didn't have to use it in the last 2 years, so I would have to look up the right example but it works. What would always work would of course be, the other thing would be you use the regular map fields utility to copy over the data from the other case under a slightly different name, like you say, okay, map the temperature from the other one to T other in this case, and then you subtract the two of them. But there is something that's called mapped. I think it's even in the options of funky set fields. Let me see. Yeah, there is, exactly. You can specify here other case, and then you can, I think then it's called other or mapped. I would have to look this up. Usually my catch line with this is I only wrote this stuff. This doesn't mean that I know how to use it. But yeah, sorry.
Okay.
Okay.
There's 2 more questions here I think we can get to in the last 2 minutes. The first one is, do you think it's possible that in the future PyFoam or swak4Foam will be integrated into OpenFoam directly?
PyFoam, let's say PyFoam is completely agnostic. That's installing that is a one-liner. That's basically pip install PyFoam. If pip is on your machine, which is usually the case, that installs PyFoam. So there's no use. I think it's no benefit to integrate it. A older version of swak4Foam gets compiled into foam extend. So foam extend pulls a version of swak4Foam and compiles this usually. And ESI, the ESI version, ESI, they now implemented something quite similar. It doesn't have the same functionality, I think, yet, but I forgot what it's called, but they implemented something quite similar, but it's not integrated. So I think it won't be integrated into the ESI because they have their own thing now. And for, let's say, psychological reasons, I think it's very unlikely that it's ever integrated in the foundation release. For social reasons, let's call it like social reasons. Okay, yeah, so so basically the bottom line is ESI has something similar. Foam extend integrates it to a degree, and foundation release will never get it integrated. You have to compile it on your own. But okay, it compiles for all 3 of them. Okay.
And one last question here, and then we can head out. Is there functionality to obtain filtered quantities of higher order, not the classical map fields, which is of order 0?
I'm not. What was it? Higher order or?
Yeah,
higher.
Is there a functionality to obtain filtered quantities of higher order, not the classical map fields, which is of order 0? I'm not exactly sure. So it's from Lorenzo. Do you have a clarification, Lorenzo? Are you asking, is it like higher order interpolation?
Yes, higher order. If I want to obtain, for example, I have a DNS and I want to obtain the filter quantities to do an a priori LES, I can use the map field, but the interpolation is of order 0 in the sense that it takes only a spatial average? Is there a functionality to obtain a better filter quantities of higher order in terms of interpolation?
To put it quite bluntly, I don't think so, because stuff like interpolation, I usually wrap myself over the functionality that is already present in PyFoam. So there are no special interpolations. I use there are function objects to map things around, but they use the same, they use the PyFoam functionality.
Okay, thank you.
But it could be possible to write a function plugin for such a thing, but I haven't done something like this.
Okay, well, Bernard, we're at the end of the time. We thank you very much again for being a trainer for us once again. And thank everybody for attending. And if you have any questions, or want to follow up, I think Bernard might be the most, have the most points on the Hoover app, so you can find him there. And get in contact with him, and I'm sure his contact information was on there as well. So I'll let the follow-up questions go that way. And thank everybody for turning out. And we have a short break, and we'll see everybody at 10:15 to start up the last technical sessions of the day.
Okay.
Thank you.
Bye, and keep splashing.
Yeah, yes. Bye now.